So we're solving nonlinear systems. The first one says let's solve this by substitution. So we'll do it like so. Let's take this bottom equation and get a variable all by itself. How about we get like y all by itself? Let's do that for this bottom one. What's our first move to get y by itself? Subtract x over. And then we will need to divide everybody by a negativo. And this is what y totally equals. What we will do is take y and totally substitute it in to the top equation where there was y. Remember, you're always taking that and like putting it in parentheses because this -3 has to get distributed too. So we'll rule like so. And now we'll have some fun. Not. What is this, 1992? Distribute the the -3. And your most favoriteest thing in the algebra world is going to come right on back and just greet you today. This is a quadratic equation, and we'll need to solve it. First, there are some like terms right now, so let's combine those together. X squared minus 4x minus 12 equals 0. And because there's x's and x squareds in the entire equation right here, that you have to solve the quadratic by any of these methods. That'll work for you. You could use the quadratic formula if you wanted to. You could factor it if it can factor, or you could complete the square if you wanted to. I feel that since the a value is 1, we will totally try to easy factor this. So, can you find two numbers that multiply together to be -12 and add together to be -4? I know some of you are very, very good at factoring. Some of you have a hard time with factoring, so I'm just going to talk you through in the medium. Tell me about the signs of these two numbers if they have to multiply together to be -12. Are they both positive, both negative, or one negative? One positive, one negative. So when thinking, I hope you're thinking through it this way. These don't work, Camry. These don't work because they don't add together to be -4. Go to 2 next. Does any of these work in this situation? Sorry. Do any of those work in that situation? So wouldn't it be these bad boys right here? Let's easy factor this to be x plus 2 times x minus 6 equals 0. And you solve with the zero product property. What value of x makes this bad boy 0? If x was -2, or what value of x makes this guy 0? 6. Now, like I said, some of you, this is just no big thing to you. You've been factoring for years and you get it. Some of you have been factoring for years and still have a hard time. You let me know if you need help, and I will help you with factoring. But I'm not going to go over that at this time. You'll have to get me on your own time. But most people would type this into my math lab, and that's not right. They didn't want to know what the x values were. They wanted to know where the ordered pairs are, where these lines intersect. So what we got to do is we got to go substitute back in, and we're going to get those two ordered pairs. If x is -2, would you believe that y would be -2 plus 4, which is 2? Is that okay for you? So here's one ordered pair of -2, 2. And if if x was 6, y would be 6 plus 4, which is 10. So remember, we were looking for where this parabola and this line intersected on the graph, and we discussed how they could intersect in possibly two places, maybe one place, maybe no place. Here's those two places, these ordered pairs right here. Next one, use substitution to solve this system. So let's do that. Look at this yummy, delicious guy. Y is already all by itself. So I could take this box and substitute it in here. And notice there's just a plus 1 y in front of here, so I don't really even have to distribute anything. So it's the 2x minus the x squared minus the 2x plus 8 equals a 4. Do you see how I substituted that stuff in for y? And this has x's and x squareds until we clean things up a little bit. Something really, really nice is going to happen. Here's 2x. Here's minus 2x. Don't they add up to be nothing in that case? So bye-bye x's. You're left with negative x squared plus 8 equals 4. And this one, you do not need to factor or use the quadratic formula or anything like that because there's not x's and x squareds in it at the same time. Is it totally possible for you to get x squared all by himself on one side of the equal sign? Do that, please. Get x squared all by himself. And then once you get x squared all by himself, you can square root. And don't forget, geometry has ruined you. It's not just 2. It's also what else? 2 or negative 2. Before we continue, I couldn't do that back here. I couldn't just square root because it had x's and x squareds in the same equation. So quadratic formula or factoring is how we'll roll. This one, haha, we just square rooted both sides. So if x is 2, I'm totally going to go up here and take this guy, which is the easier one to deal with, and figure out what y is. Would you believe that y is negative 2x plus 4? You don't have to do that if you don't want to, but I think it's easier to figure out what y is if you solve this guy for y. So y would equal, put the 2 in there, negative 4 plus 4 more is goose, and 4 plus 4 is 8. So ordered pairs 2, 0, and negative 2, 8. Sorting. This dude right here is a weirdo. He's going to make a circle. Those are pretty difficult for students to type them in their graphing calculator. You've got to know how to do that carefully. I say don't worry about typing it in your graphing calculator. Let's solve this with algebra, with substitution. This guy, piece of cake. Get y by itself. And then, if I wouldn't warn you, most of us would probably make a huge mistake when we go to substitute this in. The old arch enemy of an algebra student is the binomial squared. So you have your x squared plus bing x plus 3 squared equals 89. You can't just square the x and square the 3. You've got two choices. Either write x plus 3 times itself 2 times in a row and FOIL it out if you don't know the shortcut, or use the shortcut, which is square the first guy twice the product, square the last guy. So I'll let you do that. Meow. Square this binomial. It was square the first guy twice the product, square the last guy. You can do that with a neighbor. Square the first guy twice the product, square the last guy. This has x's and x squareds in it, so I would combine like terms and see what's going on here. So x squared and x squared is 2x squared. 6x has no one to play with. And I'm going to get this guy equal to 0 by subtracting 89 over. Two choices at this point, factor or complete the square. You could use, I said complete square, use the quadratic formula or factor. If you wanted to factor it the way it is right now, you could not easy factor because that a value is not 1. Unless you think back to the magic first step of factoring, which is the 3 beautiful letters of G, C, F. Is there a GCF between those guys? 2. Let's get rid of the 2 by dividing every term by 2. So that's nice. Now we could easy factor this if we could find two numbers that multiply together to be negative 40 and add together to be 3. If your Algebra 2 teacher told you this shortcut, good for you because you had me. I doubt that the rest of them told you this shortcut, but it only works if you're trying to find two numbers that multiply together to be a negative. Like if you're trying to find two numbers that multiply together to be negative, here's a trick for you if you can handle it. This number right here in pink tells you how far apart those two numbers would be. You need to find two numbers that multiply together to be 40. I know they're supposed to be negative 40, but we're going to forget about the signs for a second. Multiply together to be 40 and only 3 apart. Here's what I mean. Would you believe 1 and 40 totally multiply together to be 40, but are like 39 apart on the number line, right? So that's not it. Even 2 and 20, those are 18 apart. 3 doesn't go into 40 at all. 4 goes into 40. 10 times, but those are 6 apart. But how about 5? 5 goes into 40 how many times? 8 times. Would you believe that those numbers are 3 apart? So that means you got to go messing with their signs now to get them to multiply together to be negative 40, but still add together to be 3. So shouldn't the 5 be negative and the 8 be positive? So that's x minus 5 times x plus 8 equals 0. And then you could solve with the zero product property, meow, 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 and substitute back in. I'll let you do that with a neighbor. So solvent x could be 5 or negative 8. Subbing back in, if x is 5, y is going to be 3 more than that. Or if x is negative 8, y is going to be 3 more than that, so negative 5. And as ordered pairs, 5, 8, or negative 8, negative 5. Circle. X squared is y squared, same coefficient, plus in the middle. Weirdo burrito. All of those we used algebra on because I totally feel that algebra is the easier way to do those. You could do them graphically on all of them, but it's a pain in the rump to graph a circle for one, and then you got to find the right window. But this guy, in no way do we want to even try to do it with algebra because he's got some cube stuff with it, right? So graphically it would be much better. Let's go ahead and punch both of these homies into our calculator. And I know we're a little unfamiliar with the cubic, but that's the slippery little snake. That's what he should look like. And this is what graph right here, the bottom guy. He's a parabola. So if you kind of have a little preview of what they're supposed to look like, you can punch those pups in. And once you get them punched in, I always go to the standard window with a little zoom 6 to see what's happening. And I'm supposed to see like a slippery little snake and a parabola. And with a colored calculator, it's not too bad to see that. With a black and white calculator, it's more difficult to see that, you know. So no offense if you have black and white, but it is kind of not the easiest thing to see which graphs were what. But can you see bada boom and bada boom? These two places are where they intersect. Let's go finding them. Second, calculate. Choice 5. First curve, hit enter. Second curve, hit enter. And when there's more than one place, the guess is going to go find whichever one the cursor was closest to. So it went and found this one at 4, 0. Some of y'all's calculators might say like 4.00000 or 3.999999, or even the 0 might be at like something with an E with it in scientific notation. You got to outsmart it, and it's at 4, 0. So like that, comma, find the other one. Second calculate, choice 5. First curve, second curve. Now you got to move the cursor closer to the other dude because it's going to just find whichever one's closest. And I got 6, 0. And then the real frustrating thing about my math lab will be you put both of those in with the comma in between. You didn't make any typos, and it's going to say not correct, even though we have done nothing wrong. There are more answers than this. Those are only the two that you see. This is why I don't like the graphical method, because you have to change the window and find it. But first, let me explain to y'all how I know there's more answers. Number one, see this old Mr. Slippery Snake, would you believe he goes down forever this way? Like it's going to keep going down, 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 down. Mr. Parabola is also going to keep going down forever, and they're going to run into each other somewhere down here. So instead of zoom 6 in it, which is the standard window, I taught you that other thing. You remember what that other zoom fit was? Zoom what? Zoom 0, and zoom fit that dude. And there you see that other brother right there. Sometimes it works real good, sometimes it doesn't. So if I zoom 0 that and do second calculate, choice 5, first curve enter, second curve enter, move this homie over yonder, you'll get there. -6, -720. I totally wouldn't have went straight to zoom 0 though, because then you have a hard time seeing these two, especially if you have like a black on black graph where it's all black. So you'll never see that there's two places right there. So I did standard window first to see if there's anything normal, and then I just said, all right, maybe I better zoom fit it to see if there's some wacky wackertons in this case. So that other one was at -6, -720. Sound okie dokie? wrote. Last problem of the day, baby. I'll let you guys read it. Give it a good read. Pause the video, give it a read. Usually the number one question is, what does market equilibrium mean? I say, just keep on reading. Market equilibrium occurs when supply equals demand. So here's the supply function, mu, 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 mu. Here's the demand function, mu, 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 mu. Let's set them equal to each other. Q squared plus 804 should equal 1200 minus 60Q. Setting these pots equal to each other because that's where supply would equal demand. I just substituted, this is what P is, so I substituted that in for P. This is quadratic. It's got both Q's and Q squared, so I'm going to get them in the right order by moving stuff over. Q squared plus 60Q. And I need to do a little subtracting. Subtract 1200 over. Is that negative 396? Is that right? And that equals 0. So this is a quadratic equation where it's still got Q's and Q squared. You got choices to factor this. If you can factor it, I really, even though A is 1, I really don't want to waste my day trying to find two numbers that multiply together to be negative 396 and add together to be 60. So I am totally going to use the quadratic formula. The only thing that's bad about the quadratic formula is if you don't know what it is, it's pretty tough. So you might want to write it down if you don't remember it. Opposite of B, plus or minus B squared minus 4AC all over 2 times A. And I understand that you guys are not the best at that. For our fault, the math department has not had you use the quadratic formula very much. You have factored, and we have done very little quadratic formula. So I'll show it to you like if you were a brand new Algebra 1 student. You got to figure out who A, B, and C are. A is the number in front of Q squared. B is the number in front of Q. And C is the negative 396. Let's substitute these in. Opposite of B, plus or minus square root of B squared, 60 squared. You should always punch that in if you don't know. But if you know what 6 squared is, it's really not that complicated. It's 3600. Minus 4 times A times C all over 2 times A, which is 2. And then because you have a final exam that is multiple choice and all kinds of questions will ask you about this magical number underneath here, I will just keep calling it by its right name so you remember that. It's the discriminant. Grab ye old calculator and find the discriminant. It has nothing to do with the square root symbol. Don't use the square root symbol. Do the 3600 minus 4 times 1 times negative 396. Just literally punching those in. Get this big old honker, 5184. So 5184, I have no idea if that's a perfect square or not because I only make a list that goes to 15 squared, which is 225. So I would like to see if 5184 is a perfect square by square rooting it. And, haha, it is a perfect square. So that became a 72. Then it's been a long time, or maybe you've never had to do this, like clean this up. So we have to use the plus or minus. So it's negative 60 plus 72, which is 12. You got to figure that out first. Then it's over 2. Or negative 60 minus 72, which I believe is negative 132. Before I clean that up, do you understand where the 12 came from and where the negative 132 came from? 12, negative 60 plus 72 is 12. It's over 2. And negative 60 minus 72 is negative 132. These can definitely clean up to be 6 or negative 66. Then you got to go answer the question. They say, how many of each little thing do you have to make or sell or whatever they're doing to get market equilibrium? What do you think? 6 products or negative 66 products. Yeah, we got to throw the negative one away. Even though it's the algebra part, it's 6, whatever the heck they're doing in that case. Sometimes both of them, you know, you never know. They could both make sense. But in this case, we got to throw the negative one away. That, you could have factored that if you wanted to. That would have taken forever to try to find those two numbers. So we used the quadratic formula to do that. And we just threw away the negative. This is something I will not provide for you on a test, though. If you want to use it, you better know what it is, the quadratic formula. Okie dokie? Let's do some homework.